Hello everyone, this is Mohammad Alabbasi, a PhD candidate at the University of Liverpool. My PhD supervisors are Mr. Asterios Agkathidis and Dr. Han-Mei Chen. The topic is developing a design framework for the 3D printing production of concrete building components, a case study on column optimization for efficient housing solutions in Saudi Arabia. The main focus of this paper is to develop the current practice of reinforced concrete frame structure, which is the main method for housing construction in Saudi Arabia. This kind of construction approach has shown different inefficiencies, such as the lack of labor force in Saudi market and the lack of quality as a result of the lack of skilled labor, in addition to the long construction duration. The Saudi Ministry of Housing has established a new initiative called Building Technology to support new novel technologies in construction section in Saudi Arabia, especially in housing construction. The aim of this research is to improve the overall cost efficiency as well as to decrease the material consumption, in addition to decrease the required labor for in-situ construction. So the research questions are: the first one, how can we develop a design and fabrication framework for a typical single-family house in Saudi Arabia? Second question, how can the use of robotic technologies increase construction efficiency in Saudi Arabia? The third question, how can the reinforced concrete frame structure of such a house be optimized and prepared for 3D printing? The process in this research has been divided into 3 phases. The first phase was to develop a parametric frame structure of a typical Saudi villa. The second phase was topology optimization of concrete column. The data for the column was extracted from the first model from the parametric model of the frame structure. So the last phase will be verifying the effectiveness of the framework. This slide presents the first phase of our research, which is developing the concrete frame structure of a typical Saudi villa. And as you can see here, the plan of the villa can be changed, the room can be modified, and also you can add an extra room or also subtract a room if you don't need it. So the overall design will be based on the client. The client can play and see it in 3D. And also you can choose the number of story for your proposed design. So the second phase was to extract the data from the previous phase to implement topology optimization for one of the columns in the parametric house. So in this stage, the boundaries of the column, in addition to the objectives of the optimization, have been set, and also this algorithm was connected to Karamba and Grasshopper to show a real-time result simulation of the structural performance and behavior of the optimized model. And as you can see here on the right side, all of the stress and the maximum deflection and the result of the optimized column. So the last phase of this research was to connect the result of the topology optimization through slicing algorithm. The slicing algorithm was connected also to the RoboDK, which is an offline simulation software to simulate the fabrication of our proposed model, and also to generate the tool path for the robotic arm. So and also, as you can see here, the overall uh, framework of our research can be verified from design to fabrication just in one single step for all of the three phases. So the key findings of this research that the overall cost efficiency can be decreased by decreasing the required labor inside, and also by minimizing the waste of material. In addition, to minimize the construction duration. And also, as you can see here in this figure, the design to fabrication process can be shortcut just in one single step through our proposed algorithms. That was it, and thank you for your attention.